All right, so we are working on Module 4, Lesson 7. This is 7th grade. We're going to look at markup and markdown problems. So we have this problem here. It says, Games Galore Superstore buys the latest video games at a wholesale price of $30. The markup rate at the Games Galore store is 40%, so which means they bought it for $30 and they're going to raise it 40% to sell in their store. So how much would we wind up paying? So the first thing they want us to do is come up with an equation. Now the equation we're going to use is going to be your whole times your percent will equal your part. And in these cases, for markup and markdown, the part is going to be the number that you add back into the wholesale price or the number you take away from the wholesale price. When we take away, that would be like a markdown. That's going to be like a discounted item. Okay, so our wholesale price here is $30. So we're going to say 30, and we're going to times that by 40%. Now 40% as a decimal is 0.40, moving it 2 places to the left. And since they just want the equation right now, we're going to put P here. So that's just the equation. Now down here, they want you to actually solve. All right, so we're going to do $30 times 0.40. And if you do that on your calculator, you get 12. So $12. Now, you're not paying $12 for that video game. You kind of have to think ahead. Go, wow, they bought it for 30 and they're selling it for 12. That company is going to go out of business. So what you do is, since this is a markup, we're going to add it back in. So we're going to say 30 plus 12. And how much are you and I going to pay? We're going to pay $42 for that video game. And how much profit does the company make? They're going to make that $12 in profit. They're not going to make $42 in profit because they have to pay back the $30 that they used to spend on that particular item as well. All right, so let's move it up here. We now have to write the total markup for the game. Well, we already found that, so we're just going to put $12. So you and a friend are discussing the markup rate, and they say that they had a faster way of doing it by just saying 30 times 40%. Do you agree with him? Well, that's exactly what we did. 30 times 40% is the exact same thing as 30 times 0.40. It's the exact same thing. So yes, we agree with them. That's how you solve the problems. All right, let's move on to the other side here. We're going to talk about Black Friday. Now, Black Friday, as we all know, are days that they very much discount items, usually around the holiday time. But sometimes you can get an extra discount if you show up at a certain time. So here we have a $300 mountain bike, okay? And it's already been discounted 30%. So everyone will get the 30% discount. But shoppers who show up before 5 a.m. get an additional 10% off. All right. Now, because of the word additional, we have to separate these problems out. You cannot combine 30 and 10 and make it 40 because it's actually not a 40% discount. And I'll show you why. So the first thing we're going to do is the first discount. What is the discount everybody's going to receive? So we're going to say 300 times 0.30. All right. So when you do 300 times 0.30, you're going to get $90. Now that's $90 off. Okay, so we're going to take 300 minus $90, and everybody will pay $210 for that mountain bike. But those who show up before 5 a.m., they get the 210 plus an additional 10%. So when you do your second discount, you're taking it from the already discounted price. Don't go back to the 300. So we're going to say 210 times that decimal 10, being that 10%. And that will save you an extra $21. So we're going to say $210 minus 21 comes out to $189. So this is how much you would pay if you show up for the Black Friday time of getting there before 5 a.m. All right. Now I want to show you on a calculator why we cannot do 40%. So a lot of times kids think, oh, let me do 40% and just, make this problem go a little faster. No, because if we watch here, I do 300 times 0.40, That's $120 off. All right, so let's do 300 minus 120. You would have paid $180. We actually paid $189. So they're close in answer, but they're two totally different answers. So you have to go one discount and then the other discount. And that's because they use the word here of additional. All right. So let's go ahead and drop that down. Now, all in all, how much money did you save? How much was discounted? Well, we had $90 on the first discount. And we're going to add that to the $21 discount. So this is if you got both discounts. You're going to save a total of $111. So we're going to say $111 saved. All right, I'm going to pull this up. Now, I just mentioned that it's not 40%. So I'm actually going to prove that to you now. So it says after both discounts were taken, what was the total percent? So we're going to actually do line equals line for this. It's asking for the percent, so that's where our X is going to go, is in the percent area. After both discounts, we paid $189, and it was originally $300. So we're going to cross multiply, and we get 300X equals 189, and stick 2 zeros on the end. This is asking me 300 times what gives me this? Well, I don't really know. So when we don't know, we divide, and that gets rid of the 300 there. You divide this out, and just to show you on your calculator here, okay, so we're going to say 189.00 divided by 300. You're going to get 63. Now, that's not a 63% discount. You pay 63%. So we had to pay 63% of that mountain bike. So how much was the actual discount? That's when we go 100% minus 63%. will equal 37%. So the total discount was 37%. So if you check it on your calculator, because remember I told you 40% was not correct, if we do 300 times 0.37, we get 111. Well, isn't that the amount of money we had saved? Yes. But just to double check it, you can do 300 minus 111, and we get 189, which is what our discounted rate was. So when they tell you you're going to get a 30% discount and then an additional 10, you can't go, oh, that's 40%. No, it's actually a little less. All right. And that's because they're taking that additional 10 off of what's already reduced, not off the original price. So again here, instead of purchasing the bike for $300, how much would you have saved if you got there before 5 a.m.? We already solved this. So we're just going to say $111 again. All right, let's go to the next problem here. Sasha went shopping and decided to purchase a set of bracelets that were already marked 25% off. So they're $44 over here. So we're going to say $44, and everybody's going to get a 25% discount because they're already been marked down. But she came on a special day, and she gets an additional, there's that clue word again, additional 5%. So again, I can't add these together and make it 30%. You have to do them separately. So let's do the first one first. So we're going to do the first discount. That's 44 times 0.25. Okay, when you do that in your calculator, you're going to get $11. Now that's $11 off because this is a discount. So we're not adding this one on. So we're going to say 44 minus $11. Everybody would pay $33. Now, because she came on this special day, she gets an additional 5%. So we're going to take that off of the already reduced price. So 33 times 0.05, make sure you realize 5%, you go 2 places to the left, you need a 0 there, is going to save you $1.65. So we're going to take 33, we're going to minus $1.65, and this comes out to a total of $31.35. So this is how much she's going to pay because she showed up on that special day. And again, if you did this on a calculator, you did 44 times decimal 30, thinking you could add these, you're not going to get this. All right, it's a little bit higher. All right, let's look at this golf store here. I'm going to pull this up. So a golf store purchases some clubs at a wholesale price of $250. So this is what they paid for it. They turned around and they marked it up an additional 200%. They want to know, is it possible to have something greater than 100%? And then what was the retail price? So we have two answers here. So the clubs are 250 wholesale. So that is 100%. The company paid 100% of that 250. So if they sell it for just 100%, that means they're selling it for 250. So they have to mark it up. And the markup is anything higher than 100%. So I already answered this question here. Yes, you want it to be higher than 100%, or the company's not going to make any money. They're going to break even. So what you want to do is add in that 200% markup that they created. So 100% plus the 200, they're actually tripling the cost of that item. Why? Because they first have to pay back the 250 to themselves because they're in debt 250. And then this here is going to be their profit that they're going to create. So 300% as a decimal, we move the decimal 2 places to the left and it makes it just 3, which is why they tripled the price. So we're going to say 250 times 3. How much would you and I pay for these clubs? We would pay $750. Okay? And again, they would take $750, they pay back their $250. We'll just kind of do this off to the side here. The question didn't ask for this, but I just want to show you. So they're going to take that $250 sale, they're going to raise it up to $750. And so when they take their $750 and subtract it from their $250, they're going to get a $500 savings. Okay? That's $500 savings in the sense is money that they get to pocket. This is profit. Okay? Or they can save it and purchase other items with that money. So that's how that all works. So the 100% goes to the wholesale price that they purchased. They bought 100% of that money or that item or whatever you want to think of it as. They raised it an additional 200%. So in all, they actually tripled the price of this item. Okay, they didn't double the price of the item. They tripled it on this one. So here it says, was this a true 200% markup? Yes, because if we took $750 and we divided it by 250, this gives us 3. And then if we times that by 100%, we're going to get back our 300%. So to break this down, 100% of that goes to pay back the original item, what they purchased, or to clear their debt, if you want to think of it that way. Then the other 200% was pure markup. Markup / profit, however you want to think of it. So there you go. So yes, it was a markup of 200%. All right, let's move on to the next ones here. All right, a car normally sells for $20,000. It's on sale for $16,000, and then there's a sale tax of 7.5%. So what is the percent of the original car price? So again, we're going to use this formula. All right, but I don't want you to confuse this percent sign with this. This percent is not percent markup or markdown. This is a tax. Tax is totally different. It may have a percent symbol next to it, but it doesn't mean this percent. So our wholesale price or our original price was $20,000. Okay, we don't know the percent, so I'm going to use the percent sign there instead of making 2 X's. But we do know the sale price is $16,000. So this is asking me 20,000 times what gives me 16,000? Well, I don't know. So I'm going to swoop that down below here and divide that out. And I divide it out, I get 0.8. Now 0.8 as a percent is 80%. Now that's 80% that we pay. All right? So that is asking us what percent of the original price is the car or the final price. So it was 80% that we pay. What is the discount now? So that's when you take 100%, subtract it from the 80%. So how much was the actual discount on this car? It was 20%. And you have to think logically. They're not going to take a car, $20,000, and mark it down 80%. That would be crazy unless it was like falling apart. Okay? They're going to mark it down 20%. That's a reasonable markdown. All right, now C here says, by law, we have to insert the tax. Does it matter where we put the tax? So we're going to split the screen here. What if I tax the $20,000? versus what if I tax the $16,000? Does it matter in the end with my final purchase price? So here we're going to say $20,000, and we're going to times that by 0.075, because again, moving this 2 places to the left. All right, and now 20,000 times 0.05, if we do that on a calculator. So hold on, my calculator died on me all of a sudden. 20,000 times 0.075 is going to give us 150. No, $1,500. Excuse me, $1,500. Okay. Now, $1,500, this is my tax, which means I need to add this money back in. So we're going to say 20,000 plus 1,500 gives me my full sticker price of $21,500. Now, again, remember, we're going to pay 80% of that car. So we're going to minus 20% off of this, basically. So we're going to say 21,500 times that 80% that we're responsible for paying. And we're going to walk out paying $17,200. Now, that is with tax and discount. Now, over here, I already have the discount price. So I just need to put in the tax. Now, my question here is asking, does it matter when it's applied? Will I get the $17,200 in the end? Let's see. So I'm going to say 16,000 times that tax again of 0.075, and I'm going to get $1,200. And again, that's my tax. So I'm going to take 16,000 and I'm going to add back in that $1,200. And in the end, I'm going to pay $17,200. And again, that's with tax and it was already discounted. So does it matter? No. You're going to get the final price at the end anyways. The tax may be different, how much you pay in taxes. If you notice here, I paid $1,200 and over here I paid $1,500. But in the end, you're still going to pay the same purchase price. And what we just did there is called commutative property. All right, so commutative property is basically showing that we could do this math in 2 different directions and still get the same answer. All right, so we could say $20,000 times the 80% that we do have to pay times the 7.5% tax, okay, is the same thing as saying we could do $20,000 times the tax right away and then take the discount of 80% or the 20% off and we pay 80. Either way, we're going to get the same answer. And the reason why is because with multiplication, you can do the order differently and still get the same answer. All right. Now, this next section here is the side that I'm going to be grading, but I do want to help you out here with one thing. Your 5 possible pairs that you're going to pick, I would like everybody to pick the same pairs, and it's going to be 10, 20, 30, 40, and 50. Now, X is actually going to be your S, because they wanted you to use S up here. And Y is going to be the P, because they wanted you to use the P. So you're going to create an equation here, and then use that equation to solve for Y. And then down below, you're going to graph those. All right, so this here would be all your S numbers, and here would be all the P numbers. All right, and then you do the question on the other side. So that ends this tutorial.